Hello, and welcome to this video on integration by parts. We're going to use the integration by parts formula to find the integral of x cosine of x dx. The integration by parts formula tells us that the integral of u dv equals uv minus the integral of v du. We get to match what we were given with the left-hand side of the equation, the integral of u dv, and we want to use the equation to get a right-hand side that is easier to work with. So we need to make u dv equal to x cosine of x and then dx. Usually when x is part of the integrand, the function we're integrating, and we want to use integration by parts, we choose u equals that x. If u equals x, then dv is the rest of the integrand along with dx. So we have cosine of x dx. If u is x, then du is dx. And if dv is cosine of x dx, then v is the integral of cosine of x dx. And we can use a chart of integrals or a table of integrals to find this integral. This integral is sine of x plus a constant, but we ignore the constant. Then what we can say is that the integral of u dv, and that's x cosine of x dx, is u times v, and u is x. V is sine of x minus the integral of v du, and v is sine of x, while du is dx. So we get x sine of x minus the integral of sine of x, and the integral of sine of x is negative cosine of x plus some constant that we can always add to the very end of the expression. So we're getting x sine of x plus cosine of x plus a constant c. We know that choosing u and dv the way we did worked because when we rewrote the integral we were given in terms of another integral, we found an easier expression, an expression that is nicer to work with. X sine is just x sine, and the integral of sine is minus cosine. Right? Thanks for watching. If you have questions, make comments, and I will try to answer your questions as soon as I can. Bye-bye.